Welcome, everyone. My name is Julian. I'm the moderator of tonight's event, and I'm very, very happy that all of you are here now. So this is, in fact, the edition number 8 of our meetup series. And today we have two great speakers. One is Merve from Hugging Face. She's talking about responding to disasters using NLP. And then we have also with us Kacper from Qdrant about the current state of multilingual semantic search. And as I said, although this is already the number 8 event, I'll give you a short introduction into how this works. So we have these two talks. Each talk is about 30 minutes. And at the end of these 30 minutes, we already include questions and answers. So expect the talks to be between 20 and 25 minutes. And then you can ask your questions. This meeting is being recorded and we will upload it later on to YouTube. You can also ask your questions in the chat and write them down there. I can read them out loud. And then after the two talks, so in about 1 hour, we will also have breakout rooms where you can then in shorter, smaller groups discuss with the other participants and also with the speakers. And yeah, now without further ado, I would say, Kacper, the stage is yours. Please share your screen, and we're very much looking forward to your talk.
Great, thank you, Julian. Thanks for the invitation. Yeah, I just need to switch to my slides for a second. Okay.
Yes, that works.
Hope you can see them already. Great. So, as already said, I will be speaking about multilingual semantic search and how to perform it nowadays, because there have been a lot of going on recently in terms of supporting many different languages by the same embeddings models. So definitely we need this sort of review. If you work with less popular languages, this is also crucial to have a strategy of how to handle that. And yeah, today I would like to speak about several topics. First of all, I would like to introduce you to the topic of semantic search. I'm pretty sure that some of you might be not really familiar with semantic search and how it is different from the previous attempts to solving search. This might be surprising for some of you, so definitely this sort of introduction might be helpful. Then we are going to have a small overview of the paid services which are available, because they became really popular recently. So I just feel that that should be also shared of what you can expect depending on the service of your choice. But there are, of course, some self-hosted or open source models. That's a different thing. Of course, we can have some models that we will be hosting on premise, but that doesn't necessarily mean the models are open source. And since we believe in open source in Qdrant, I feel that that's the proper way of doing the semantic search with multilingual support. I would also like to speak a bit about the challenges that we currently have with multilingual semantic search and how it is different to semantic search done in a single language, typically in English. And I would also like to share the strategy of how to handle multilingual search, including some less popular languages, because that's also feasible. And it seems like there is a quite simple framework that might be simply used to extend the capabilities of the existing models. But first of all, let's start with the semantic search. I'm pretty sure that many of you have already heard about semantic search and what it brings above beyond the keyword-based search that we used previously. But I would also like to share some comparison. Basically, keyword-based search is based on the presence of some specific words or tokens in the text. And it actually tries to find the relevant documents based on the presence of those words, based on the overlap between the terms used in a query and the documents that we have collected. There is an assumption that we need to know, we as a users of the search engine, we need to know what terminology was used in the documents that we are trying to search over. And that's a huge drawback of the keyword-based search, just because in some more complex domains, it may be simply hard to find proper wording to write a query. I'm not sure if you remember the old systems used in the libraries, in which you could find some books, but only if you knew the title. At least that was the system that my university was still using while I was studying. It wasn't that long time ago, but basically those systems were not as user-friendly as they could be. But we are pretty used to keyword-based search. If you use any sort of e-commerce system, if you are looking for a specific product, you are probably using some sort of keyword-based search with some additional heuristics applied on top. The keyword-based search by default will struggle with synonyms. So we either expect our users to provide the same word as we used in the documents, or we can also configure it so it handles some synonyms. But that actually requires providing a full list of synonyms that we want to support. So this is basically quite hard, and in the world of really fast and rapid change, that may be really tough to maintain. And another thing, keyword-based search won't handle multilinguality. Basically, this is typically as every single language that we want to support needs a separate pipeline. So definitely that's quite hard, because we need to know the language we would like to support, and that's not always the case. And thus it requires some configuration. And there are a lot of tools that are quite commonly used for that, like Elasticsearch or OpenSearch. So those are pretty well known. But there is another approach that has been introduced a few years ago, and this is based on some neural embeddings. Neural embeddings are vector representations generated by deep neural models, typically transformer-based nowadays. So those vectors are trained in a way that two different pieces of text, let's say paragraphs, but maybe also words, but two different pieces of text will have a similar vector representation. That means we measure the similarity using some distance function, cosine distance function or Euclidean distance function are quite commonly used here. And we train those networks in a way that two pieces of text will have similar representations if they describe a similar thing. So that already captures the synonyms out of the box. We do not need any further configuration, but that may also handle different languages if we train the network in a way that it will be providing similar vector representations for different languages, and that's completely doable. And since there are some pre-trained models available, we don't need to start from scratch. Those might be further fine-tuned to support not only to support the languages that they were originally trained on, to support them better, but also with some new languages if we at some point need to extend them beyond the original languages. And this is actually, semantic search is actually based on KNN in some derivatives of that algorithm. So this is fairly simple algorithm that everybody who attended some machine learning classes was taught on some primer classes. Definitely that's one of the simplest methods, but it doesn't scale that well. That's why we need some proper tooling, and there are tools like Qdrant or Vice. And semantic search requires two processes to be done. Basically, there is one process. Well, in a nutshell, we have some neural encoder, and we use the same encoder to encode both queries and documents into their vector representations, and then we use the similarity function of our choice. And here we have a graph describing so-called bi-encoder architecture. So we use exactly the same model to create the embeddings of both queries and documents, and then we compare the distance between those two. And the first process I mentioned is the process of indexing the data. Here, this graph shows how we could tackle that in case of question answering. Basically, we put all the answers, all documents that could possibly answer our questions through the neural encoder, and we convert them into the embeddings. And those embeddings are then stored in the vector database of our choice. And there is another process that we fire whenever we receive a question or a query. That gets also vectorized through the neural encoder, the same one as before. And the question or query embedding is sent to the vector database, and our vector database uses some similarity function, similar distance function under the hood to provide some candidates. So basically, this is it. Those are the two processes. And that may, depending on the model we choose, that may support different languages using the same vector space. And this is pretty cool. And by different languages, I don't necessarily mean languages like English and Spanish, but that might be also a different terminology being used. I really love this example of office emails. If you write a lot of office emails, you probably know that the meaning of those two sentences are quite similar to each other. And if we look at some vector embeddings that could be possibly generated for those two, you can already see that they are rather close to each other, just because the numbers at corresponding positions are quite similar. And that would also mean that the distance between those two shouldn't be that high. So those previous sentences got vectorized into some similar representations, and those two as well. But if we compare the vector embeddings of those two sentences that I'm displaying right now, they are really far away from the previous example, just because the meaning of those two is completely different. But there are no low-hanging fruits in semantic search. There are two challenges that we need to solve. First of all, we need to have some models which are trained properly on the languages that we want to support. And that's not an easy process. That's really cost and time consuming, but also data consuming as well. We really need lots of data to train those models from scratch. So we typically base them on some pre-trained ones that have been already trained, and those are typically available on Hugging Face hubs, but also in some different libraries as well. And in case of multilingual semantic search, we not only need a model that was trained on any language, but we need to support them all. So all the languages of our choice should be already included in the training data. But there is also another challenge of semantic search. We need some efficient tools. As I already said, pure KNN, pure k-nearest neighbors is really slow if we want to go beyond, let's say, thousands of vectors. Imagine we have like millions of embeddings created in our database, and we are still using pure KNN. Then for each query, we would need to compare to every single embedding that we have collected so far. And that makes it really slow. So there has been a lot of going on in terms of approximate nearest neighbors. And HNSW is one of the algorithms that is quite commonly used. But I need to say that the second piece is actually already solved, to be honest. But those two challenges reflect in the two components that we typically need to handle, typically need to host somewhere, and those just need to be glued together somehow. But when it comes to tools for semantic search, there are vector databases, and Qdrant is one of the examples that uses HNSW under the hood. It's written in Rust, and you can interact with it using two different protocols, using distributed clusters. But there are also some additional mechanisms like category, geo coordinates, or full text filters. So if you need to look for some specific documents using semantic search, but you also want to provide some additional filtering criteria, let's say you are looking for a piece of cloth, you probably want a specific color, and that might be another thing that cannot be really captured by the vectors. That has to be provided somewhere else. But that was the end of the self-promo. Right now, I would like to speak about some available tools because there are already a lot of services that may provide you those embeddings, so you don't need to host your own model on your infrastructure. That can be used quite easily, and I really like those services, not necessarily by the fact that they are closed. That's a huge disadvantage. I really love open source and openness in that domain, but basically they allow you to start prototyping really fast. And they have been already trained sometimes a really huge set of languages. So that really enables quick prototyping, and that's the thing that I really love most about them. And everybody is talking about ChatGPT and its impact on the society as well. But OpenAI was also working on some embeddings, and there is a specific API we can use to obtain the embeddings. However, if you would have a look at their website, it's quite hard to find some information about the languages they do support with the latest embeddings model of the second generation. That's actually the only one that is marked as suggested to be used on their website. The first generation of models was extremely expensive. Right now, the prices were reduced quite a lot. So that's actually one of the posts on their website. This second generation embedding model from OpenAI does support English, and sometimes you can have decent quality for different languages as well. But you cannot really expect it to work for any kind of language you could choose, and it's quite hard to base any kind of multilingual semantic search on a model which is just not reliable. There are also some other issues with OpenAI APIs. To be honest, the stability is not something that we could really rely on. But there are also some other providers as well. And Cohere embeddings. Cohere is another company that offers those embeddings as a service. They support over 100 languages, and there is a full list of those languages displayed in front of your eyes right now. So that looks like a decent set of languages. So if you expect your users to use only those mentioned ones, then you are free to take the model as it is and use it for your multilingual semantic search applications. That works pretty well, and comparing to OpenAI, Cohere embeddings are also way cheaper, and you don't pay for tokens, which are quite hard to be predicted, but you pay for a single embedding created for you. But there is also another provider, this time European-based, Aleph Alpha, and they offer a model that supports 5 languages out of the box, those 5 popular ones, let's say. So this is fine if you work with this limited set of languages. But the cool thing about their model is that the multimodality is already built in. So you can provide not only some textual queries, but some images as well, and those will be also converted into the same vector space. That's somehow similar to clip models, which are commonly used for that. But that's it when it comes to embeddings provider. Probably there are some other companies offering the similar services on the market, but those 3 are the ones that I've worked with so far. And well, this world is really changing so rapidly that it's really hard to follow all the new startups that go into the market with some embeddings APIs. But there is also a lot of self-hosted encoders, or actually models that you can run on premise. By self-hosted, I didn't mean that they are open source. The weights are public, but the whole training process and the data that was used in order to train the model are not. That's an issue, because well, we cannot really make any assumptions about the data that was used. Right now, there are also some legal processes around using data for mid-journey like models. So the same thing may occur also in case of the models that we do not know much about the training phase. But basically, there are a lot of them available. And of course, there is a huge difference in terms of the number of languages supported by them. As you may see, a lot of them are provided by Google or Facebook, and there are a lot of them that you can actually you are actually free to take and use. And as usual, there are some standard libraries that are used, and sentence transformers already provide you with some pre-trained multilingual models. So you can just take sentence transformers, which is probably the most popular library in that area, and you will have the support of several languages out of the box. But there is a problem. It's quite hard to choose the best model in our case. And the problem with that is related to the fact that benchmarking in multilingual semantic search is really hard. In English, we have several benchmarks available, with MS Marco and BEIR being one of the most famous ones. But in case of multilingual data sets, things are way harder. Just because there are no publicly available large multilingual data sets that would be enough to benchmark the models in all the languages. And we typically need to limit ourselves to some specific subsets. So then comparing the accuracy between or precision between different languages is quite hard. There is also HELM, which stands for Holistic Evaluation of Language Models. It actually aims to benchmark the language models and is hosted by Stanford. But the problem with that is that there are no non-English scenarios presented right now on their website. The only benchmarks that were done were focused on English. So that's not the proper way to look for the benchmarks. This comes from the Cohere website, and actually they tried to compare themselves to some other models. And when we look at the search multilingual column here, we can clearly see that they beat all the models that have been previously used. The problem with that is I couldn't really find the benchmark that was used to back this statement. So definitely in some cases that might be true, but I would really appreciate having some more public benchmark available just to confirm that that's really the case. But there is one benchmark published by Google that's called Extreme that focuses on cross-lingual transfer evaluation. And basically, that already supports 40 languages from 12 language families. So that's pretty decent number. And that's also a good place to start to look for some benchmarks. And there is already a list of the models. There is a leaderboard that we can filter by language. So in case you are looking for a specific language, that might be a good place to start with. But I also promised to speak about a strategy that we could use if we work with a less popular language. That happens quite a lot, even if we take a model that supports over 100 languages out of the box. that might be not sufficient in some specific cases. If you come from a country and speak in which you speak some less popular language, you may still struggle with finding a good model. But there is already a strategy that has been described in a paper displayed below. The paper comes from 2020, so it's not like the most recent one. But basically, it covers a strategy of how to use some pre-trained models in order to fine-tune them for a completely new language. And that's really a simple strategy, but it also turns out to be really powerful. It also assumes that we have two different models. First of all, we have a teacher model. So that's a neural network that has been already trained for a specific language. Typically, it would be trained on English because that's the most popular language. But that might be actually any different system that you can actually find. And we do not assume much about the structure of those networks. We also have student model, and the whole goal of this of the training is to train the student model in a way that it will be producing similar representations to the ones produced by the teacher model for this language that is being supported by the teacher model. But at the same time, we also want to encode the same sentence written in a different language. We want to encode it using the same network to a similar vector representation. So that's really simple strategy. The only thing that we need to provide to that framework is a so-called parallel data set in which we have pairs of documents written in two different languages. So that has to be some sort of translation of those sentences, and then we just put the let's say the English version of the sentence through the teacher model, and both sentences through the student model. And by calculating the mean squared error loss, we are able to fine-tune the student model in a way that it will be producing similar vector representations to the teacher model. And the cool thing about this setup is actually that we do not really need to know the weights of the teacher model. We do not assume anything about the network that is being used under the hood. That might be a completely different structure compared to the student model. This might be a system that we do not know much about. Well, actually, we could also use one of those paid services to generate those embeddings and then use those cached embeddings to reproduce the results. That's also feasible to be done. But typically we take an existing model that publicly available pre-trained existing model. And during the experiments reported in the paper, they were using SBERT as a teacher model and XLM Roberta as a student model. That's mostly because this XLM Roberta has a different tokenization mechanism, so it can be extended to some new tokens as well. So we avoid the issues with mapping some unknown tokens coming from a new language to unknown token most of the times. Basically, this is it. This is like a simple framework, and the overall goal of that setup is to optimize the following objective function. We want to minimize the distance between the embeddings generated for both source, so-called source sentence, and T comes from target. So we want to optimize the distance between source sentence generated by those two models, and we only train one of them. Basically, this is fairly simple yet powerful. And if we look at the results, it seems that the authors were able to extend the model for a completely new language that is called Tagalog. the language that is used on Philippines. And the student model was not trained originally on this specific language, even though they were able to achieve over 84 points of accuracy using only around 36,000 of translated pairs between English and Tagalog. And that may seem to be a lot, but in reality, that should be feasible to be collected, not necessarily by a single person, but if you work in a company, that's a number that you should be able to collect in relatively short time. And that's a good strategy if you would like to extend any model to support a new language. Even if that language was not originally used in the student model, that is still feasible. Well, I put some references to the materials that I used while preparing this presentation. So if you would like to read some of the papers that I read, feel free to take the title from that page. But there are also some references to the GitHub repositories at which you can find, for example, the source code of this knowledge distillation method. So you can also reproduce that on your own using a different data set that you may possess. And if you have any questions, I would be happy to answer them. Otherwise, you can also drop me a message using my socials, and this QR code will point you to the Qdrant's website. So thank you very much.
Yeah, thank you very much, Kacper. Very inspiring, very great talk. I especially liked how you emphasized this open source spirit and the self-hosted models.
Yeah, I believe in open source. I think that's the future. Of course, there are a lot of going on in that area. Thanks for OpenAI and all the other companies, but definitely open source is the future. I strongly believe in that.
Yeah, with that statement, you're a great fit for the Open NLP meetup. I very much like that. Yeah, let's see whether there are some questions. So from the community, feel free to write something in the chat. You can also unmute yourself if we aren't too many with questions at the very same time. I have also a couple of questions, so I'm pretty sure there are some questions in the community. Let's see. Don't be shy.
Well, if there are not, we can also leave them to this meeting rooms, and then we can discuss them in more details.
Yeah, let's see. So I started a question. Maybe more people come up with questions. So it's in this open source direction, and my question to you is whether you think that this open source community that we have will catch up with the existing commercial proprietary models, whether it will take some time or whether they will always be a little bit smaller, let's say, these models, the data sets, because of the costs.
Well, yeah, there is a problem that's training those models, and handling that requires lots of money, and that's an issue with catching up for all the open source activities. But actually, I had several talks around ChatGPT recently. Actually, everybody speaks about that, so that's quite common for everybody, I believe. But many companies that would like to invest in using that has some issues with using some closed source projects. I believe that business has a lot believes that open source is a way to implement different things, just because they have more control over what's happening and where their data is being sent to. So I believe we'll definitely catch up with that. But that's undeniable that those businesses that are also driving this hype really crazy. So but I really believe that we are going to have some cool open source projects developed during this year that maybe won't beat the commercial ones, but will be so close that there won't be much difference for the end users.
That's good news. There's a question about knowledge distillation and about the number of pairs of tokens. So I think the number of pairs of samples that you need. I think you mentioned it already, something like 36,000.
Yeah, that was the one of the examples. Actually, I've chosen this example, but if you have a look at the original paper, they mentioned all the languages they used. But this is especially impressive because that's one of two examples in which they used relatively small number of pairs for a completely new language, and they will still able to get some decent results. So that's really exciting because yeah, that's not that much. Definitely, I would say that not that much. So yeah, but as you said, that was 36 sentences translated between English and Tagalog.
And another question is about these very large language models, like sentence transformer models. Whether you would say, from your experience, that it's still worth fine-tuning them on somebody's own data, or that it's sufficient enough to use them?
Well, if you use them for some general knowledge, let's say, they should be fine enough. But if you work in a specific domain, then definitely at some point you will need to fine-tune them so they work better with the terminology that you use in that specific area. We have lots of users that actually try to fine-tune them just because they are not satisfied with the, let's say, default quality, but still that's a way faster approach than trying from scratch. So definitely they have to be fine-tuned unless you work with some general knowledge data.
All right. So there are a couple of more questions in the chat, but I'd say because of the time, maybe you can answer them in the chat.
Sure, I can do that.
That would be great. And then we can already continue with our second speaker.
Great,
thank you so much again. Yeah. All right. Yeah, then let's go to our second talk of today. And the second talk is by Merve. Hi, Merve. If you want,
Hello.
you can already share your screen. So
I was planning to share. Okay, let me just do that. Present. So I prepare my my talks with Canva often, and I was wondering if I could just drag and drop some PDF and it would work, but let's go with this.
So we can see your screen already, yeah?
Yep. Does it work?
Yes, now it's full screen.
Okay, great.
So yeah, I mean, then without further ado, very much looking forward to your talk. I think you did something really inspiring, really admiring.
Thank you.
Looking forward to this talk.
Well, we made it with Tuana, who actually works at DeepSet, and she was very involved in the NLG part of it. So hello, I'm Merve, and today I will talk about something amazing that we have done, but a quick introduction. So I work at Hugging Face, and I'm mainly working on natural language understanding. So I was pretty happy with Kacper's talk because it makes me happy to see open source NLU because I firmly believe in it. And this talk is about the part applied machine learning at Open Machine Learning Network, which is a volunteer organization in Turkey that developed this project called Afet Harita. So this is the project that I will show you. And what happened was that on 6th of February, there was like 2 big earthquakes hitting an area as big as from Paris to Amsterdam. And it's not like an exaggeration. It was very big. It was very deep. And there were like many people dying, like tens of thousands of people are dying, and probably hundreds of thousands are being injured. And this was the statistics in like 2 weeks or something. In the meanwhile, the earthquakes kept happening. And due to this, people were under wreckage because unfortunately not everyone is following the safeguards to build a safe construction building. And because of this, there were people who were under wrecks, and they were being saved by mostly NGOs and individual people. And we were like, at least I was having a bit of a survivor's guilt in the meanwhile, and I wanted to do something. And like one of my friends have texted me saying, "Hey Merve, we are doing something in this Discord server. Would you like to join us?" After, I would say, like 4 hours when the initial earthquake happened. And I went to there, and we realized the common pattern among how survivors were saying that they are there. So basically they were either posting screenshots saying, "Hey, my name is this, and this is my address, and I am still alive. Can you please save me?" And then we realized there was a lot of people like this, and like posting these on either Twitter or Instagram and waiting to be rescued. And then we decided to do something about this big mess of data, because this was like thousands of people posting it, and it was impossible for authorities to actually see all of these in a structured manner. And yeah, like we convened in the Discord to roll out some applications, but like at first we didn't even know what to do. Like there was like 20,000 people in the Discord. Of course, like most of them aren't active, but and also we didn't really come up with like solid product ideas. It was rather that, hey, we can actually do this, and we would go ahead and implement it. Like there was absolutely zero product management or whatever, because it's just an application, and we had to race through time, because like after a while, like once people are rescued, then there is different needs. It's freezing cold over there. People are staying outside, and they are like thirsty, or like they are freezing to death. So there was like a lot of problems, and we had to race through time, but like not make any mistakes with the models that we were training. So initially we were asked to build an optical character recognition app with an address parser model connected to it, and we prototyped something. So the problem definition was there was tweets and screenshots consisting of calls for help, an address, and what people needed. Like after people were rescued, they were also stating that they needed hygiene products, they needed shelter, they needed blankets, and so on. So we needed to also structure the needs into that. And we needed to extract text and then address and then the needs because of this. So because I work at Hugging Face, and Hugging Face is sort of this GitHub of machine learning. It's not like an insertion of anything, but like it's rather that we built a bunch of collaboration tools together in Hugging Face Hub. And so I was like, I feel like it's the easiest way of collaborating, because like if we were to do all of these and build products and stuff and like deploy them, like GitHub doesn't necessarily have the best tools for machine learning. It's more for code. And like we were like, yeah, let's I just created this organization. I am like the first member of it. And then I started noting down what we have in this organization card, and like, yeah, like people started joining as contributors. And at the first place, we started building this OCR application in which we have used Easy OCR. And at the first place, so basically what it does is that you have a screenshot that you can upload, or like you can upload what do you say, text. And then if you upload a screenshot, it will parse it into text and then extract the entities and then structure them and write it to a DB that's, you know, like the other applications can see. At the first place, we had to use OpenAI because we didn't have any named entity recognition models for address that we could have used. So we went with FewShot instead. But this turned out to be not as good. And plus, we didn't have back then we didn't have any OpenAI credits, so everyone was like giving away their tokens to, you know, just keep it up. And we were like, this is not sustainable at all. Like, and also a few shot doesn't really necessarily work best. And this is multilingual, and we felt like it's best to train our own model. So later we had labeled data. And our second problem was intent classification, in which we were extracting the needs, like as in like this tweet would say, hey, I need blankets and food and my family is freezing and whatnot. And like we would extract the multi-label, like in a multi-label fashion, we would do intent classification based on it instead of doing something like entity recognition. But at first place, what we did for that problem was that we tried a couple of NLP checkpoints on Hugging Face Hub, like multilingual ones, and they were actually pretty good. But for that problem, OpenAI was performing better. So we were like benchmarking everything, you know, how like we were, I think we were getting somewhere around like 0.75 accuracy in the NLP checkpoints at most. And even 1% matters at this point, but like we still didn't want to be tied to closed source, because like back then there was like Microsoft acquisition and everyone was like just using OpenAI repetitively. And because of this, it was, we were always getting rate limited. And again, we didn't have a sustainable, like we didn't have credits whatsoever from there. And we started labeling both for named entity recognition, like address parsing, and also for the intent classification problem. And this was our first open source address parsing model. And we were able to get the addresses, and then like we hosted it on Hugging Face Hub. And like, because I work at Hugging Face, we were I asked the tech people to, like infra people, to scale it for us, and like we were using Inference API, and it was open source because like I got reached out by many people saying they need such application for their application as well, as in like they were also building application for disaster response. So it was nice that other people were able to use it as well, so that we don't really put it behind the gated access like you know, like others would do. So it was using, again, Inference API, and we have got a couple of instances up and running, and yeah, but like there is like many ways to deploy this model. It was a simple transformers model. It was based on one of the Turkish bird checkpoints. I think like the best performing ones, like there were 3 of them. One was bird-based Turkish. There is a bird checkpoint released by a company called Lodos, and then there was 128K birds. Like those 3 were performing the best, so we always experimented on those ones. And this was our first multi-label intent classification model. And we were reporting we were mainly going with recall and F1 score, because we didn't want a need to be there but not addressed, but rather we wanted like, it's okay if it makes up, like it's okay if it says, hey, there is a need for shelter over here. Like this is a bit of a problem, because you start to make ethical decisions. Like even the metrics that you pick are tied to what you are valuing. So we didn't want the model to omit false negatives, essentially. So we went with recall metric. And because in multi-label, what you are doing is you have a confidence threshold, and then above that threshold, you like in multi-label, you have like multiple labels with the probabilities associated with them, and you say, hey, I'm going to determine a threshold, and I'm going to take any label that is above that threshold into consideration. And that's what we did, and we were benchmarking with macro average of recall over some threshold. We also had like there was like many ethical decisions. Like it was a bit stressful. Like even remembering this is like a bit of a PTSD for me, but I am overall like happy that we did this. There was even like an irrelevant class, like whether we need a class called irrelevant to get them out. We even did that. But in the end, this was our application. So basically what you have is you have like a map, like Turkey map, and then over that you have a heat map, and then that heat map is actually determining like the red parts are where the most reports are by means of the needs. Like if your part is red, then that place needs a lot of things so that you can provide them. And then you can, on the left hand side, you can filter it with, you know, you need shelter, you need some safe points, you need some accommodation, and so on. And also our MLOps pipeline was technically completely open source. We used Hugging Face datasets to host our datasets on Hugging Face Hub, and we experimented with transformers and we versioned our models on Hugging Face Hub. We served our models using Inference API, which is open source. If you go to GitHub, like it's called API Inference Community. And then we started to crowdsource our efforts to improve the labeling, because like the first labeling was pretty bad for us. Like it was very messy, and there was like not clear guidelines on how to label the data. And because of this, the model wasn't performing as good. For instance, to do the experiment tracking, we have done like, I put up some leaderboard, and people would report their recall and FA score. For instance, on the left-hand side, you see the best recall was 0.82. It was due to how our labels were pretty bad. And then we went for another labeling effort to improve it, and it should be like 0.95, something like that. Like as of now, it's better. And we because like on Hugging Face Hub, you have your model repositories, you can host your TensorBoard instances. We use TensorBoard to log the training runs and how it went with the loss and everything. And thanks to Argilla, we have like a Docker image of Argilla instances sort of on Hugging Face Hub. We were able to crowdsource the active learning. So people would report the bad labels and it would be written, and like we were able to later use that for the plate training runs as well. And thank you for listening, and I can have some questions.
Yes, thank you for a great talk. We already have some questions in the chat, so I can start reading them out. And one question Tuana wrote down that I also had in mind. It's about what you'd say is the most difficult part of that project, or let's say maybe the most time-consuming part of that project. So you could say it was the annotation guidelines and coming up with that, and then making annotation space of that. Could also be the model optimization, or maybe the UI. And that would be interesting, I think.
I think hardest part was actually trying to like come up with different things with people. Like like at first, like, because like there is like different opinions on what we should be using, and like we are racing with time, and it's like because of this it's hard to think. But I would say it was like we didn't set up monitoring at the first place, and that was pretty bad. Like normally in production you would have like you would write your predictions and everything in a monitoring thing, and like we forgot to do that, and like that was pretty bad. Another thing, like model training, because like we fine-tuned, but like it's not actually fine-tuning when you are like putting a head on the bird and like only training that part. It would only take like 3 minutes to actually fine-tune a model. And like the model training, I would say, was the easiest part, because we could just do plug and play thanks to transformers for different bird checkpoints, and like do hyperparameter optimization with Optuna, and like come up with models. But not having labeled data was definitely was a bit of a problem. And yeah, like it's quite hard, because like Turkish language itself is a low resource language, and it's like morphologically rich, and it's because of this it's like hard to work with. Like you don't know, like there is no free lunch theorem sort of, and like whatever that is, whatever is state of the art might not guarantee to work on it. But like we tried many things, and in the end it was the open source BERT checkpoints that worked for us. And because of this, I'm also like working to release a sort of like a glue benchmark in my thesis for Turkish language, like with machine translated data sets. Yeah.
There was a question maybe in this direction where somebody asked about other texts you use these named entity recognition models for, other than Twitter or Instagram data, and how their performance was. So using the models basically for other data.
For other data, what's...
But still Turkish, I think. Yeah, in general, I think Turkish language models. But any R for Turkish.
Can I see? Can you tell me the timestamp of the question?
8 p.m. A longer one with 1, 2, 3 points, and I chose the second one.
So following this event, have you used NER model for other texts other than Twitter and Instagram data, and how was it performance? So basically, I just remembered. So the thing is, like the named entity recognition data that you see on the internet is mostly scraped from, you know, Wikipedia or whatever. Like it's like most of the NER data sets are actually brought this way, and like because of this you don't really have addressed data sets, and like even storing addressed data sets is actually a breach of GDPR. Like once you scrape and keep it, it's against the privacy protection, so we had to anonymize them, which was another effort to do so. Like I tried different things, like I used our model, there was like a Faker API, I think, for this, and like it's not good to actually store your data set. And like because of how people reported their names, address, and so on, it's not, I would say, a like compared to Wikipedia, like the one you do with Wikipedia, like the training you do with Wikipedia, it's less context-based when you think about it. Like the surroundings, like there's absolutely no surroundings to the words. As in, you say, I'm Merve, my address is XYZ. You don't say that. You say Merve, you state your address, and then you state some, if you want to state, you state your phone number. And like, because of this, like, because people had to state it very fastly in this manner, it's almost like it's very different than how people, you know, like how you would apply named entity recognition. in other use cases. And I don't think we would actually use that NER model for other texts because of this reason. It is probably very much overfit to the earthquake region. Like, I'm not 100% sure, but like for instance, when you're stating the name of the apartment, it can feed on that because it's still context-based, because it's still a BERT model. But for instance, like extracting in Turkey, we say like 10/1 when we are saying the outer door number and the apartment, like the door in your apartment, like which number you are in. And it's pretty much overfit to that. Like, that's why it's a unique problem. I hope this answers your question.
Yeah, it also a little bit answers the question that we got, the most recent one about rule-based approaches, right? When you said the model overfits to some patterns.
Mm-hmm.
So these rule-based approaches might work for some of these patterns, but then you also have many other cases.
Yeah, exactly. And like it wasn't only this, but like we had like the BERT model, and then after the BERT model, there is some parsers to do some regex, and then we send it to Google's geocoding API, and then from geocoding API, it goes to the backend to be reflected on the map. So it's like multiple steps, and like at the end of the day, we are looking for longitude and the latitude, and like it was enough for us. So yeah.
There are two questions more about the process. So the most recent one is about any tools you wish you had during that time. And the other question is a bit in the direction of how your team of, I think, more than 100 people coordinated efforts and communicated with other organizations like rescue organizations or maybe even government bodies.
So the first one, I do like, I would say, because I was working on open source ever since, like I pretty much knew all the tools. One thing was that they would, at some point we were working on a the duplication API, because there was a lot of duplicate things, and like it was very hard to decide on how to deduplicate as well, because like, for instance, it might be same address, but it might be a different family members reporting something, or like it might be a different time. Like a family might be rescued and then they might be reporting their needs and such. I would say I wish we actually, at first, I never worked with any vector search engines or like vector databases. So I like, at the first pipeline we went with was actually reinventing the wheel. I was like, let's do TF-IDF and cosine similarity to deduplicate things. And then we realized how infeasible it is with like so many entries, and like it's quite like reinventing the wheel when you have stuff like Pinecone, or I think Qdrant does that as well. You have like many vector databases. I wish I knew them. It would like save a lot of time, but it was at that point, like people didn't know about it, I guess. And Tuana at that point wasn't in our server. She joined later on. And I wish Tuana came earlier. I should have told her. And what else? Yeah, I think there is not like, I was already a pro user of transformers, so like, and most of the stuff we have done was through transformers, and because of this, Tuana, you don't have to feel bad at this point. Yeah, like I would say it's mostly based on transformers, so I didn't really had any regrets about it. And the second question
was about coordinating with other organizations, maybe rescue organizations or government bodies.
Yeah, we did, and it was mostly through them and not through like the government bodies and so on. Like, because we have a lot of search and rescue, we had like so many people got together with the with the whole like there is like influencers who try to bring people together. We have like this big organization called Ahbab, and if you would like to donate, please donate to Ahbab because it's a good organization, like you can trust it with your money and so on. We were like basically what happened was that this server was founded by two of my friends, and like one of them was constantly communicating with these organizations, and like there was like a couple of multiple people working with him, and they were telling us, you know, what we need and what we should do. And we weren't really the people that would get in touch with them, but it was rather that we were always told about some business needs, and like it's not like business needs, but yeah, we were always told about say, hey, we have a data like this, can you do this for us? And then we would do it. And it was very chaotic because there was like a backend team and then there was front-end team, and I was like, I would spam the people in the backend saying, hey, we trained that model like this, can you integrate it in one of your products at least, so that we can actually be useful at this point? Because like they also had their own problems, like people were rolling out multiple applications, but this one at the end was the one that got millions of requests and not the others. Apparently there was a need for this, and like I'm happy I contributed in some manner. Like I believe it's I would say the hardest part, because like they made me the lead for this stuff, because like I already knew the people in the back end, I knew the people in the front end and so on, and like because most of the stack was at Hugging Face, and I was able to like build this MLOps pipeline, so on. Like they kind of trusted me with it, but like the hardest part was to actually coordinate people and like also do cross-team collaborations and stuff. It wasn't the technical problems. The technical problems, you can always solve them if you really want it. And I also am a firm believer of how like there was a discussion before my talk with Kacper, I think, like I really think like big models that are behind the closed gates are the shiny ones, but like when we benchmarked these models against our own fine-tuned models, and there was always this 5-10% accuracy gap with the models that were open source and that were specialized for that case. And yeah, like because of this, I feel like open source and in-house machine learning development will never die, and like companies will always opt for just fine-tuning BERT on a 3-minute cost of GPU and their own data, because it's like you have more control over it. You don't need to rely on someone else's infra. You can have your own infra and deploy it there. If you have a problem with the outputs, you can just get over that. And yeah, like it was points like working there kind of made me believe why I was working at Hugging Face, and I was working for open source machine learning and not the other way around. So it was like a bit of an emotional roller coaster for me as well. I was like very proud that you know, I was working with such team. They were like enabling me to do what matters and say, hey, if you want this, just use it. Like, we don't care, just tell us what to do.
Yeah, thank you so much for sharing these insights. And thank you also so much for yeah, what you did in this project. I hope it inspires many people here in this call, but also many people then later on watching the YouTube video. I'd say for time reasons, we stop it here with the Q&A and go into the breakout rooms. But again, yeah, thank you so much for giving this talk. And this is a point where I stop the recording, and then we can jump into breakout rooms. So please stay with us, and then we can have some discussions in smaller groups. So